All right, class, we're going to take a look at section 14.3, which talks about measures of dispersion. So first part of this lesson, we got to talk about range. Range is one of our easier concepts. All it does is it takes the difference between the largest and smallest values in the data set. Let me erase that last part, but I was just trying to get my marker going here. So all we have to do is figure out what is the smallest number, which is 11, and what is the largest number, which I'm seeing 21. And then you just, 35. There it is. 35 and 11 is this is your biggest, and this is your smallest. So all you do is you take your 35 minus your 11, and that gives you your overall range. Now, range it gives us a good clue as to how broad our data set is. It's not usually a very important question for a lot of math classes, but it is significant, and it does help us identify. So here we had 24, of course, and we've got another data set here, and I just want to show that it just depends on what your data is here. There's not the 11 anymore, there's not the 35, and so it just changes what our range is, and it shows us that our data set's a little bit more, it will show that we're a little bit more close together. We've got 25, and here we've got a 16, anything smaller than 16. So I just take my 25 and subtract 16, and that gives me my 9. So what we're saying is the range of this data is only 9 numbers. So in other words, it's much closer, more closely packed together than this one. There's some larger, almost outliers. So here we've got standard deviation. Standard deviation is easily described as if x is the data value in a set whose mean is that x with a bar over it, then x minus x bar, in other words, your number minus the average, is called x's deviation from the mean. Now, what we want to do is figure out, well, what is the standard amount to deviate from the mean? And to do that, we've got a long process, and I've got an acronym, and it looks bad, but it's not. It's just ASSAS. And it's a 5-step method, and so you're going to average the data set. That's the first thing, in other words, find the mean. You're going to subtract the average from each number. You're going to basically be doing this right here in the set. You're going to square the results, average the squares. So in other words, you're going to find the mean again, and then you're going to square root that final result. So yes, it is a long process, and you might want to take a picture of the last one, rewind now and take a picture. But here we're going to have questions that say find the range, the mean, and standard deviation. The nice thing about standard deviation is you had to know the mean anyway, so this is just a step in the process. But anyway, the range we have is 14. It's the biggest, 3 is the smallest, so 14 minus 3 is going to give us a range of 11. Okay, so we got range done. It's just easy. It's just like it's supposed to be like a freebie question. Hopefully it is. So the next step we have to do is find the mean. Well, to find the mean, I got to add the numbers up. So I got 3 plus 5 plus 7 plus 9 plus 10 plus 14. It's going to give us a total of 48 numbers. And 1, 2, 3, 4, 5, 6. Divide that by 6, and that is going to give us an average of 8. So 8 is my mean. So to find the standard deviation, we do our ASSAS. So we got ASSAS. So first step, found the average, done. Check it off. Now we got to subtract each number in the data set. So what I usually do is I make a vertical list of the numbers, so 3, 5, 7, 9, 10, 14. And then I subtract each one of them by my average, so 8. Subtract 8, subtract 8, subtract 8, subtract 8, subtract 8. So these are my numbers, and I'm subtracting their average, which is this x bar guy. And then you're going to get positive and negative numbers. It doesn't really matter that they're negative, but anyway, so I get negative 5, I get negative 3, I get negative 1, I get 1, I get 2, and I get 6. All right, so then I take and to do the next step. This S stands for square. I'm squaring these results. I'm taking this, squaring it. So I'm going to get 25. Take this, square it, and I get 9. Take this and square it, and I get 1. Take this guy, square it, and I get 1. Take this guy, square it, and you get 4. And finally square that, and you get 36. Okay. So now we do the next A. Now the next A stands for average. So in other words, I'm going to take and average these numbers here. And they are always positive at this step. So I just add 25 plus 9 plus 2. I'll just add those. And then plus 4 and then plus 36. So that gives me 76. So this all adds to be 76. Okay, so that was this part of the average. I got to divide it by how many numbers there are. So it's 1, 2, 3, 4, 5, 6 numbers. So 76 divided by 6 gives me my 12.6. 67, if you will. Okay, and then to finish, the last S stands for square root. So all I do is I square root that. So if I push on my calculator, second square root of the answer, and that gives me 3.56 if I round. So about 3.56. Okay, so what that's saying is the standard amount of these numbers to deviate from the average of 8 is 3.56. So what that's telling us is that if a number is further away from 8 than 3.56, it's kind of hanging out pretty far. So it's one of my weird numbers in the whole data set. And then in one of our later lessons, we're going to talk about what a normal amount does for that. But anyway, so this is a standard deviation. This is the process to do it, and here's an application of why this is important. Now, taking a look at this data set, these are tires, okay, that have been tried, different rubbers, different makeups of a tire, and this is tire A, this is tire B. These numbers are in thousands, how long it lasted for that tire before it blew up or wore out or whatever. And now this actually happens at the tire factories. They actually put a tire on a machine and they roll it and put pressure on it and act like it's rolling down the road and wait till it goes bang. And so here's what the tires did. And now what's going to happen here is we're going to do an average for each numbers. We're actually going to do the standard deviation for each one, but I want to talk about what a salesman could actually do for you. So you could add this up. Okay, and if I add that up, I'm going to get 66 plus 43 plus 37 plus 50 plus 54, and that gives me 250. And then if I divide that by my 1, 2, 3, 4, 5 numbers, what we're saying is we get an average of 50,000 miles on this tire. And if you do it down here, you're going to get the same average. So both tires, I could walk into the dealership today, tire place, and they could tell me, oh yeah, you should get an average of 50,000 miles for these tires. And if you're looking at the spread of data, you know, it's a little bit weird. And so what we want to do is standard deviation takes a closer look at these, where I can actually set these up and do the standard deviation work, and I'm going to really find some interesting analysis of this. So what I'll do is I'll set it up, and then I'll do the work, and then I'll just push play and show you the answer here. 54, 49, 47, and 48, and 52. Okay, so let's actually, I'm going to do the work, and then I'll talk about it afterwards. All right, so there you go. There's the work. We've got my work over here where I'm subtracting the average, squared the results, and then I added them and divided by how many numbers I got. So what this is my standard deviation is 9.9, which is 9.9 thousand. Do the same work on the second data set, and I get a standard deviation of 2.8 thousand. So here's what this means, is your average is 50,000 for this tire A, plus or minus almost 10,000. Tire B is the average is 50,000 plus or minus 3,000. Okay, so that's a big range, because that's saying, all right, I've got tires on one vehicle that are wearing out all over the place. I got a tire lasting almost twice as long as this tire. So if you got one tire in front and one tire in back, your tires are doing some very odd, goofy things, and you get terrible wear patterns happening. So when someone sells us something and say, oh, well, this is what it gets on average, well, what does that mean? The average doesn't mean a whole lot if we don't know how far we're expected to deviate from that average. That's why standard deviation tells us what is the standard amount that we should be deviating from the mean. So it's a very good, useful tool when we're doing statistical analysis. All right, so I hope that this was clear. If you have any particular questions, let me know through the Ask My Instructor feature.